So it's great to see you all today or hear from you all because, it's virtual. And today I don't want to go over anything new. I just want to teach you a different way to solve those absolute value inequalities. So this is for learning target 1.3. On the first test, this was that last page of problems where you had the number lines, and you had to plot it with the inequalities with like the arrows in opposite directions or together. And these problems definitely gave students a lot of trouble, but it wasn't because you didn't know how to solve them. A lot of you did the right thing. You isolate the absolute value, you separate it into two different problems, and you make one positive, one negative, and you solve each of those. But there's a lot of tricky things you need to keep track of, mainly with that inequality sign. So if you divide by a negative, it flips direction. When you write your two problems, it changes directions again. It's a lot of stuff to keep track of. And the other issue with using that method is that you can't always see if you're going to have one of those two special cases, whether there's no solution or if the answer is all real numbers. If there's any point on the number line that actually would work to fulfill that original problem. Now, in class, remember, like when I was teaching this, I'd say, make sure you check your answers. But I know realistically, that's not going to happen, right? You get into a groove, you think you've got all the steps right, and you just generally assume that your answer is correct. I mean, who's got the time to check every answer to every problem? Even though you should. So I've got a fix for you all. This is a slightly different way to solve these inequalities, which is actually going to be a little bit easier, but it might take a little bit more time. And so I'd like you to try using this new method that I'm going to go over today. Mainly because you're going to have a retest on all these targets next week. So remember, our second test is next week on Monday, Tuesday, Wednesday, or Thursday. So remember, cohort B students, you're not going to be in on Thursday, Friday. That's being shifted up to Wednesday, Thursday because you all have Friday off next week. Yay! So I'd like you all to use this new strategy on the next test. All right. And so I've got some example problems to go through. And if you can see my screen, you can write this stuff down if you haven't already. And basically, here's the new stuff. Here's the new technique for these absolute value inequalities. Mainly, this first step is you're just going to change the sign of the inequality. You're going to make it an equal sign. Okay, this way you completely remove that inequality, the greater than, less than, or whatever. That just is an extra unnecessary step to get confused with. So make it an equal sign. And that way, that's going to save you a lot of trouble as you're doing the solving. You can focus on just your basic algebra of solving for x or whatever the variable is. So you solve for your two answers. And then whenever you get your two different numbers, you plot those on the number line. All right, but again, we don't know which way the arrows are going to be going. But once you have those two numbers, those two answers, then what we're going to do is this last line, which I've got in bold. This is the big new step. What you're going to do is use something called test points in order to determine the solution, basically which part of my number line should be shaded. Because when I plot those 2 points, you're actually breaking it up into thirds. You've got a left section, a middle section, and a right section. And so you're going to pick 1 point from each of those areas and basically just plug it back into your original problem to see if it makes the inequality true. All right, so let's take a look at some of these together. Dun, 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 dun. Example 1. So I've got this inequality, and it's nice because I've already got the absolute value isolated. It's already by itself. Now the big new step here is this inequality sign. Just completely forget about it, and let's rewrite this as the absolute value of x plus 2 equals 14. All right, so that's going to take away the headache of remembering when you switch that inequality sign to the left or to the right or anything like that. So now you're going to treat this exactly like an absolute value equation, which again is something you're going to be retested on next week. And so this will be a good little review. Whenever you've got an absolute value equation, you want to isolate the absolute value, which we do have here. Like there's only the absolute value on the left side. There are no numbers in front of the absolute value or outside of it being added or subtracted. So it's all ready to go, where we write two problems. All right, this is the key step for solving an absolute value equation. We are going to write one equation where it's just x plus 2 equals 14. We don't change a thing. We don't change any numbers, anything like that. We just get rid of those absolute value bars. The second one is going to look almost identical with one big change. That number on the right side becomes negative. Okay, so we give that a negative sign. And these are going to be our two problems. So this is what we're going to solve. And on the left side, we just subtract 2, and we see that, oh, okay, so x can equal 12. It's one possibility. Over here on the right, x can equal negative 16. It's another possibility. All right. So if this were an equation, we would be done. Well, check your answers, right? If you do plug them in, it does work. Both of these numbers will work. But this is an inequality, remember, because this is target 1.3. And so what we're going to do is take these two numbers and plot them on a number line. Make sure the smaller number is on the left. So in this case, the negative 16. So we'll put a bar there for negative 16. The 12 would be to the right. Those are really the only numbers I need to see, and just make sure they're in the correct order. So this is our number line, and we need to determine which part of this number line has like all the good answers. Now, if we kept the inequality, we know that normally we're going to have one of two scenarios typically. Either you're going to have two arrows like pointing away from each other, or that bridge connecting these two numbers. But there's actually 4 possibilities. The other possibility, number 3, would be that the answer is all real numbers, meaning you're going to not even have any arrows. It's going to be every part of the number line is shaded. And the 4th possibility is that there's no solution, in which case you're not going to have any of this number line shaded. And so the best way to try this out is to pick a test point. All a test point is a number in each of the 3 different sections of our number line, whatever those 2 endpoints were that we solved for with the equation. Just pick a number from each of these areas, and it doesn't matter which number you use. So to the left, I just need any number less than negative 16, so I could pick something like negative 20. In the middle, I'm going to pick a number between negative 16 and 12. I'm going to go with 0 because that's a super easy number to work with. And on the right, a number bigger than 12, you know what, I could even just pick 13. It doesn't really matter which number you pick as long as it's in that correct range. Now we're going to go back up to the original inequality, and now we are going to use that inequality sign. So I do need that greater than sign. So we've got the absolute value of x plus 2 is greater than 14. So here's what we're working with at this point. And I'm going to test it 3 times with each of those 3 test points, the negative 20, the 0, and the 13. So I'm going to say, all right, so the absolute value of negative 20 plus 2 is greater than 14. So all I did is I plugged in that test point of negative 20 into my original absolute value inequality. And we're just going to solve this problem and see if it's true. Does the left side equal the right side? Negative 20 plus 2 is negative 18. So we've got the absolute value of negative 18 greater than 14. Now when you take the absolute value, it just basically gives you the positive version of that number. So is 18 greater than 14? Is that a true statement? I'm assuming you're all saying, yes, absolutely.
It is.
Thank you. Yes, it is. So that's a true statement. That tells me that this area to the left of the negative 16. So here's my negative 16. And basically, since that point to the left was true, it made the inequality true, that means I'm definitely going to be like shading that area, right, to the left. But I still need to check these other points just to be sure. So now let's try the middle section. All right, my test point in the middle was a 0. So I'm going to write the absolute value of 0 plus 2 greater than 14. And we're going to see if this is a true statement. 0 plus 2 is 2. And the absolute value of 2 is just positive 2 again. And here we've got the statement 2 is greater than 14. Well, 2 is not greater than 14. This is not true, so that means we are not going to be shading in this middle part of our number line. Now we have one more value to test out, and that's going to be this 13, or whichever number you pick that was greater than 12. So I'm going to plug in 12 plus 2 greater than 14, and we're going to solve this. And, oh, I'm sorry, I used a 13. My bad. Let me erase that. 13 is my test point, not 12. So I've got the absolute value of 15. We're seeing if that's greater than 14, and sure enough, 15 is greater than 14, which means that area works to the right of the 12. So if we were to shade this in on the number line, I am going to have an arrow going to the left and an arrow going to the right. So that is our number line. It is the opposite arrows. The last thing we would do is write out that final inequality statement. Now, if they are opposite arrows, we have to write it as two completely separate inequalities. We have to say either x is less than negative 16, or, so we have to use the word or whenever you've got arrows pointing in opposite directions, because x is either less than a negative 16 or x is greater than 12. It cannot be both of these, right? You can't have a number that's bigger than 12 and also smaller than negative 16. It just doesn't happen. And so that's the new technique. Let's try it again. So I've added some more steps to this one, but I still want you to treat these the same way, where you kind of ignore the inequality and just change that to an equal sign. All right, so I'll give you a few seconds to write this down because I know there's a lot of numbers here. It's 4 times the absolute value of 6 minus 3x plus 8. And originally it was a less than 20, but just for now, we're going to make that equals 20 to help us get those two endpoints. That's always our first goal, to get the numbers. And most of you were really good at that. On the test, I remember almost all of you could get those two numbers correctly. You just didn't know exactly what to do with them once you had those answers. So when you're solving an equation, always cancel out whatever's being added or subtracted first. So I'm going to subtract 8 from both sides, which gives me a 12 on the right. Then we divide by the 4 that's in front of the absolute value because it's being multiplied, so we have to divide to cancel it out, which gives us a 3. And now at this point, we have isolated the absolute value. So this is not a 16. Remember, that is a absolute value bar. And now we're going to write our two equations and solve each of them separately. The first one will be just 6 minus 3x equals 3. We don't change anything. The second one is 6 minus 3x equals negative 3. So here's where we change the negative sign. Also, I noticed a few students would make this 20 back in the very first step. They would start by writing two equations right off the bat and make one equal to 20 and one a negative 20. And that is not the case. You cannot switch the sign until you get the absolute value all by itself. So make sure you follow those steps, isolate the absolute value, then write your two separate problems and solve each of them. All right, so I'm going to subtract 6 from both sides. 3 minus 6 is negative 3. And then we divide negative 3 by negative 3 and we get a positive 1. That's going to be one endpoint. Over here, I'm going to subtract 6, we get a negative 9, and x equals positive 3. So those are our two endpoints, and we're going to plot these on the number line. Make sure the smaller number goes on the left, so that would be a 1. To the right of it is a 3. And so our goal right now is to try some test points. And so just pick any number to the left of 1. I'm going to use a 0. Again, that's a great number to use. A number in between 1 and 3, well, we have some limited options. I'm going to use a 2. And then a number greater than 3, let's just use a 4. So we're going to use these test points back with this original inequality. And remember, we do need to use that inequality sign. We need to keep that less than in place now. All right, so let's start by plugging in a 0. I've got 4 times the absolute value of 6 minus 3 times 0 plus 8, and we want to see if that's less than 20. And as we work this out, well, 3 times 0 is 0, and 6 minus 0 is 6, plus 8 less than 20. The absolute value of 6 is still 6. 4 times 6 is 24. And then 24 plus 8, that is 32. And so now look at this inequality down here. Is 32 less than 20? No, it is not. So that tells me that all this area to the left of the 1 does not make it true. So that is not part of my solution. Okay, let's try this middle section. I'm plugging in a 2. 4 times the absolute value of 6 minus 3 times 2 plus 8, and we're seeing if that's less than 20. All right, so 3 times 2 is 6, and 6 minus 6 is 0. So this is 4 times the absolute value of 0 plus 8. We're seeing if that's less than 20. Well, 4 times 0 is 0, and 0 plus 8 is 8. And then our inequality now says, hey, 8 is less than 20, and that is true. All right, so I know this middle section is going to be part of my solution. Last, we've got to check out that number on the right, which is a 4. So I'm going to plug a 4 in for x, and I am kind of running out of room, so let me work that out over here. And again, this is being recorded, so if I am going kind of fast, you can always rewatch it later. So we've got 4 times the absolute value of 6 minus 3 times 4 plus 8 is less than 20. All right, so now inside that absolute value, I've got 3 times 4, which is 12. And 6 minus 12 is negative 6 plus 8 less than 20. And now though, because I've got these absolute value bars here, the absolute value of a negative 6 is a positive 6. And 4 times positive 6 is positive 24. And 24 plus 8, that's 32. And this is not a true statement. 32 is not less than 20. So then this area to the right is not part of our solution. Our only solution area is going to be this bridge in between the 1 and the 3. So in this case, whenever your solution is that bridge in the middle, this is where you write that 3-part inequality. And so you just basically write these numbers from left to right. So my left endpoint is a 1. Then I'm always using less than signs, or less than or equal to signs if that's in the original problem. X goes in the middle, another less than, and then the right endpoint. So 1 is less than x is less than 3. All right, so this way you don't need to worry about which way the arrows point necessarily. It's just going to get you those endpoints and you're testing it out. But the real power is going to come into play. I'm going to skip that one. With a problem like this, all right? So this is going to be one of the special cases. Spoiler alert. Now, one thing I do want to bring up, I saw a few students on the test who would look at these numbers up here and they would actually add them together, right? And say, oh, this is 11 times the absolute value of x, blah, blah, blah. But you cannot do that. That violates the order of operations because this 3 is actually being multiplied by the absolute value. And so when we're solving an equation, don't think of combining things on the same side as the x. You want to think, how can I get rid of each thing individually that's on the same side as the x? So I want to get rid of whatever's being added or subtracted first. So I'm going to subtract that 8 from both sides. That leaves us with 3 times the absolute value of x minus 1 is less than negative 6. Now I can divide by 3 on both sides to get rid of that 3. You have to get rid of each of those numbers separately. Please do not add them together. So we've got the absolute value of x minus 1 is less than negative 2. Now, on the test, some of you got to this step and you recognized right away, hey, if I'm taking the absolute value of something, is there any way that it could be less than a negative 2? And the answer is no, right? When you take the absolute value, you get a positive number. And a positive number will never be less than a negative number. So if you get to this step and you recognize, hey, wait a minute, that's a less than sign, I can't do that, then you can just right away say that there's no solution. There's no value for x that would make this true. However, not everyone's always looking for that. And so that's why I said you can always just use this new technique. We're going to make this an equation and then use some test points. All right, so I've got my 2 problems. And I've got x minus 1 equals negative 2. Over on the right, x minus 1 equals positive 2. We're going to solve each of these. So x equals negative 1. That's going to be one endpoint. Over here, x equals 3. That's my other endpoint. So we've got our number line. And negative 1 is on the left. 3 is on the right. And we need to use these test points. Pick one point from each area of this number line. So negative 1, pick a point to the left. Let's just go with negative 2. Keep it small. In the middle, I always love using 0. To the right, let's just use a 4. Doesn't really matter what we use. And now we need to go back to that original problem with the inequality sign. So I'm going to use this original problem. For testing out our test points. Okay, and so what's going to happen is I've got 8 plus 3 times the absolute value of, here's that test point of a negative 2 minus 1 is less than 2. And then when I solve this, remember order of operations, so we cannot add that 8 and 3 on the left. I have to figure out what that absolute value is first. So I've got a negative 2 minus 1, which is negative 3. And the absolute value of the negative 3 is a positive 3. Right? So I guess just to show you, this is 8 plus 3 times the absolute value of negative 3. So this is 8 plus, now the absolute value of negative 3 is positive 3. 3 times 3 is 9. And 8 plus 9 is 17. And so we've got 17 is less than 2. Well, that is just not true at all. So this doesn't work. Okay? In the middle, we're going to test it with the 0. 8 plus 3, absolute value of 0 minus 1 less than 2. This is 8 plus 3 times the absolute value of, well, 0 minus 1 is negative 1. 8 plus, well, the absolute value of negative 1 is positive 1, and 3 times 1 is 3. 8 plus 3 is 11. And is 11 less than 2? No, of course not. So that's not true. So the middle section is out. Now at this point, you might recognize, hey, if the left section's gone and the middle section's gone, it can't possibly be just the right section, because we're never going to have an absolute value inequality where you have just one arrow. It's always either two arrows in opposite directions or that middle section. And so if we do plug this number in, though, just to show you, 8 plus 3 times the absolute value of 4 minus 1 less than 2. That's 8 plus 3 times 3. Absolute value of 3 is 3, so this is just 8 plus 9. And we see 17 less than 2. Well, that also is not true. So even that third section did not work on our number line. So there's no point to the left, no point in the middle, no point to the right. If this happens, what do we say the solution is? No solution. All right, so this is why this method is a bit more beneficial, because you can easily see when there's no solution. You don't have to worry about trying to think it through like in the middle of the problem, because usually you're on a roll, but you don't typically stop right here when you recognize, oh wait, this was originally a less than sign, and an absolute value can't be less than a negative. All right, the last scenario, we don't have time to go through this whole problem, but here's what would happen. We're going to have our endpoints, right, for our two numbers. I don't remember what the numbers are for this one. Let's just say they're like, I don't know, 3 and 10. And we use our test points. And for this scenario, the test point to the left would work, the test point to the middle would work, and the test point to the right would work. And so in this scenario, it's the opposite of that previous problem, where every single number works in all three areas. So in this case, you would write all real numbers to show that, hey, every single possible number is a solution, anything to the left, to the right, or in the middle. So this is the new technique, and I want you to try using this on the test next week. And I can tell you that there will be at least one special case on this next test with the absolute value inequalities, either the all real numbers scenario or this scenario where there's no solution. So what I would suggest doing is go back into Delta Math and go through some more practice problems on target 1.3. Because even though I only required you to do, I don't know, like 7 of them, and with the level 3 difficulty problems, you can still continue to do more than that. In fact, you want to do more than that so that you are going to be ready for the test on, Monday, Tuesday, Wednesday, or Thursday next week based on your group. So hopefully this helps out. It makes it a little bit easier. I know some of you were struggling on that Delta Math still, and so this is a great way for you to use to make sure you get it right. Anyways, that's all I got for today. It's 10 o'clock. If you have any more questions, email me later. Bye, everyone.